Good morning, all of you. I am from Vijayamar, Department of Physics, SNS College of Technology, Coimbatore. Already, I am taking in first topic is composite materials, and this is becoming a second topic, the case study on smart materials. So, the smart materials is a very important role to the form of the most of application and research oriented side. So, I am taking in the second one case study is in a smart materials. Before on that, we know that three word: stay home, stay safe, and work at home. This three we do that in this COVID-19 period. So we are safe mode and safe home and safely working in our nature of work. So let us start from my topic is smart material. First of all, we discuss what is smart material. Material, we know that the strong and shape and color and colorless and different form of things, matter of form is a materials, and form in nature is different properties. So the properties we have changed from that, the material it executed in the new property in a same material, that we call this a smart material. So the clear definition of smart material is the properties change from that shape, color, or size in responding to that, to the applying of such different property in the same material to the form of stress, light, temperature, impurities, pH values, and the different types of field of electric and magnetic. This all to be applied that the material is changed from that the longitudinal or horizontal or some property will be produced. For an example, electric field or the shape will be changed. So based on this property we have applied in different application from the different field of. The next one slide is the classification of smart materials. So the classification from the smart material I mentioned in 5 types. The one is in a photovoltaic, and another one is in a magnetostatic, third one is a thermoelectric, fourth one is in a shape memory alloy, and fifth one is in a rheological fluids and others. So this material, the mostly we discussed in that in our study of nature. The one is piezoelectric. This is we studied from in a mostly in ultrasonic production. Then second one is in a magnetostrictive material. This also we have studied from ultrasonics. So the production of ultrasonic, these two method we have used in the most of times. Then third one is in a thermoelectric material. So let us see in one by one of the classification of the smart materials. The first one is piezoelectric materials. The piezoelectric material, the principle is piezoelectric effect. What is piezoelectric effect? The piezoelectric effect is we know that when a mechanical stress is applied in a piezoelectric crystal, it execute the equal and opposite charge from in opposite phases of the applying force. So it's forming only for piezoelectric crystals. The crystal structure already we know that the two side is pyramid and it's formed in hexagonal structures. It's a X cut and Y cut nature. This all we studied from the ultrasonic production of piezoelectric oscillators. So the piezoelectric effect we have applied the same nature from here also. The one energy is converted to the another energy. That is a basic concept of the piezoelectric effect. So we applied the pressure, the charge will be executed in opposite side. So this diagram is clearly explained to the form of pressure is applied in one side, that is active mechanical controller side, that is mechanical energy is applied, Then the opposite side is an charge, that means electric field or electrical energy is conversion. So the converse of piezoelectric effect, it's a form of actuator or transmitters. The piezoelectric effect we used in the most of sensor, microphones, hydrophones, and power generators. This all we have used it. So the one of the very important smart material is a piezoelectric material. The second one, is a magnetostriction material. It's a similar to the piezoelectric, but we use in some particular material from the magnetostriction material, that is ferroelectric material. The ferroelectric is mostly consists of iron content. So in right hand side I form in some material tabulations, that is material tabulation, material magnetostriction, Curie and temperatures. So based on the temperature, the Curie and material properties must be changed. You look at that, the most of is form of Fe. So the concept is that the same, the force or displacement we applied, the stress is applied or the stress is removed from the material, the voltage or current it produces. So the material shape or size, it will be changed, that I mentioned in H, B and lambda. This all the property to the discussed about that applying of the stress, it will be changed in longitudinal nature. So that is a magnetostricting material. It also one of a protection of ultrasonic material method waves. The next one, the thermoelectric materials. The thermoelectric materials I'm formed in the diagram is semiconducting material, N type and P type elements. So these elements to be absorbed in heat absorption. The heat is sink it, then it converted to the electrical energies. Then electrical energy is saved from that. So the most of thermoelectrical material is a smart material. Why we say is a smart material from thermoelectric? We applied in thermal absorption in material. After removing of this absorption in material, that means it's a normal state to be returned back. That is a elastic nature to the form of semiconducting material. Especially from this semiconducting material is based on that nature. That material is only to be applied for thermoelectric materials. This is the third one. The next one, yes, this is very important material, shape, memory, alloys. So the combination of the material to the form of alloys, we know that the shape, memory, it's a form of to applying combination of the material wise, right? So this has become wide area we have applied from that day-to-day life. For example, aeronautic, medical, and robotics, pipes, etc. So the smart materials mean when we have applied the stress from the material, it's change in shape or size. Then we remove the stress from the materials, it's written back that the same shape or size. So this word we already discussed from the elasticity. So this elasticity nature to the form of rigid material, that material is called is smart material. Already we discussed in first slide, that the same point of view we discussed from here also. Shape memory alloys, so it's a exhibit in a two very unique properties, form of pseudo electricals and then one way, two way shape memory alloys to based on shape memory effect, right? It's a one of a very important smart material. Example is NiTi alloy and copper, zinc, aluminum alloys. This all is a example of shape memory alloys. The next one is a rheological fluids. You know that micro robotics is a similar to the form of liquid robotics. What is liquid robotics? The liquid to form in the shapes to the form of flower or any other triangles formations, that is a liquid robotic. So this liquid robotic to the based on to the applying of that feed from the liquid, its form in nature of the shape or size. The removing from the stress, that means field of the material, is written back the normal fluid. So that is a rheological fluids. So it's look like an artificial formation to the applying of electric or magnetic field. Mostly the fluid is become as an ion formation. The next slide is very important. We discussed to the form of conclusion area, that is a feature of the smart material. First one we discussed 4D materials. What is 4D material? Already we know that the dimension wise it is 2D, 3D, like that. This is the 4D. So the 4D material is a structure that can be modified to the memories and shape after the deformation. This material are created through the 3D printing. It is a marketing that the form of 2019, but it's not developed that, but it's 2025 is form of the developing nature of 4D materials created in a application oriented in most of areas. The next one, ionic polymer metal composite, IPMC, that is another one, smart materials. So the next slide I show you is a 4D toys. So look at that, the 4D toys. We know that the 3D toys, but this is a natural original toys. That means how we see the object, it's a form of 3D, but it's a form of 4D. Is a look like in a nature is original to the form of, that is an example of 4D toys, right? So the next slide is forming. I'm taking this all the image to the form of Google reference. So I mentioned all the reference from that. Okay, thank you.